Okay, this is 2013 question 4. This is a graph analysis problem. Just based on how the graph looks, some things to note. What does the graph represent? Okay, so make sure that you guys understand that the graph represents f prime. Okay, so just keep that in mind there. They give you a couple of facts through the paragraph at the beginning there, but basically they're mentioning that there are horizontal tangents at 1, 3, and 5. And they indicated some areas there, okay? So we'll come back to that in a second. Here we go. Here's part A. Find all values of x where f has a local minimum. So you guys have to remember that f will have a local min if f prime changes from negative to positive. So look at that. We have the graph of f prime. Where does f prime change from negative to positive? Okay, so it only happens right about there. Okay, and that's at 6. X equals 6. It wouldn't be at 1 because the graph goes from positive to positive. There is no change in signs. It wouldn't be 4 because the graph goes from positive to negative. F prime is changing from positive to negative, so that would be a local max. So there you have it. I would say at x equals 6, since f prime changes from negative to positive. Okay? You could write down similar to what they wrote. I think the way that I wrote it is a lot simpler and shorter, but I'll leave that up to you. Okay? Part B. Determine the absolute min. Absolute minimum, okay? So remember, absolute extremes could occur at the endpoints, but at a critical number. So remember that a critical number is where the derivative is 0. So we actually have 3 here. We have 1, we have 4, and we have 6. 1, 4, and 6. So here's what you can do. So there are a lot of candidates here, but you could actually rule out some of them. We're looking for the absolute minimum. So just think about this here. I'll start off with the ones that are a little bit more straightforward. If you take a look at 1, okay? 1 is neither a local max or a local min. So that means that the graph is just cutting straight through. In this case, it's increasing and then increasing some more. So there's no way that at 1, you're going to have a local minimum. Now at 4, we call that a local maximum. There's no way that a local max could be an absolute minimum. So we could actually cross that out as well. 6 is a local minimum, so it's actually possible that a local min could be an absolute min. And 8, can 8 be it? Okay, we could rule out 8 as well, because if you take a look at 6, this was a local min. So let me graph this for you guys, okay? I don't necessarily know what the original graph looks like, but let's just say that this is your local min right here. Afterwards, f prime is positive, implying that f is increasing. So you know this graph has to be going up. We don't necessarily know how high it's going to go up, but there's no way wherever I stop that this could be the minimum. There's no way that that's going to be possible. So we could actually rule out 8 as well. So you went from 5 choices down to 2, okay? Now, 0 starts somewhere. We don't know. But right after 0, you notice that f prime is actually positive. So what does that mean? That means that f prime is actually increasing. Okay? So is it possible for this to be a minimum? Yes, so we do have to consider it, okay? So we're down to just 0 and 6. So basically, here's what you do. Let me see where I have space here. Okay, so we would have to integrate the derivative to go back to the function. Now, from where to where, right? Okay, so they have to give us some type of conditional value here, okay? So here they tell us that it's 8. Okay? So the thing is, you could put this wherever you'd like. I'll put it at the bottom here, okay? Now, if you put 8 as a lower bound, you actually have to consider where you started at f of 8. In this case, it's going to be 4. Okay? And the upper value is what you're interested in. So I am going to separately plug in 0. And the other one, let me see if I can copy paste this. The other one, I'll copy paste it right there. I'll erase the 0. Whoops. And I'll put in a 6 because these are our two candidates right here. All right. So a few things. Notice how that integral is kind of weird because the bounds are backwards. So you could actually rewrite it as 4 integral from 0 to 8 as long as you consider that it's a negative, okay? I personally like to do that because when I'm finding area, I like to read it from left to right. But that's really just a preference. Some people can just go backwards and just remember that it's negative. It's really up to you, okay? So remember that integrating really just means finding the area of. So for this first one, we're really just finding the area from 0 to 8. So take a look at the picture now. We're going from 0 all the way to 8. We have to figure out the total area of everything that I gridded in green. Okay? But here's the thing. What I know about those areas. It's very conveniently given. Okay? The only thing you have to remember, the only thing you have to remember is anytime the area is above the x-axis, we know it's going to be positive. So that's positive 2, positive 6, positive 7, which is a total of 15. Okay? But down here is the area 3. We just have to consider that everything below the x-axis is negative. So we have 15 at the top, 3 at the bottom. That'll give you a total of 12 positive, okay? So that's really, I'm going backwards here, 4 minus a positive 12, which gives you negative 8 like they stated in the score guidelines, okay? Now here at the bottom, we're finding the area from just 6 to 8. So from 6 to 8, the area there would just be positive 7. So that's really just 4 minus positive 7, which is really negative 3. So based on those two values, I know that the minimum is definitely going to be negative 8, and it occurs at x equals 0. So the thing is, what are they asking for? They're asking for the absolute minimum value. Value is referring to the y value there. So you would just say the minimum value is negative 8. You wouldn't say that it occurs at x equals 0, okay? So be mindful of that. Here's part C. What intervals from 0 to 8 is f both concave down and increasing? Okay, here we go. So let me give you some space here. Okay, so this is the graph of f. We want to know where f is concave down, and we want to know where f is increasing. So this is where you guys have to translate it. It's like a different language. We only speak in terms of f prime. So what do these two phrases mean in terms of f prime? So here's what I'm going to do. And feel free to pause here if you want to answer this yourself, okay? We know that f is increasing when f prime is positive, okay? We want to know when f is concave down. F is concave down when f prime is decreasing. So we're trying to find out when both of these things happen, okay? So let's first start off with this here. I want to see in the graph where f prime is decreasing, and I'll highlight it in orange. F prime, this is the graph of f prime, is literally decreasing from 0 to 1 and from 3 all the way to 5. Okay? That's when f prime is decreasing, or that is when f is concave down. Now, f is increasing when f prime is positive, meaning above the x-axis. So everything in green here is basically when f prime is positive. Okay? So the thing is, if we go back to our question, we're trying to find out when f is both concave down and increasing. So we're pretty much looking at where that orange highlight overlaps with the green highlight. So this is only going to happen from 0 to 1 and from 3 to 4. And there you go, from 0 to 1 and from 3 to 4. They wrote it as an inequality notation. I think most of you guys would just write from 0 to 1, union 3 to 4. I think that's just easier. But make sure that you explain it. Since f prime is decreasing and f prime is greater than 0. That's basically all we did there. We translated it. Okay? Here's the last one. Part D. They introduced this new function g, and g includes f, but the f of x cubed. Okay? If f of 3 is negative 5 over 2, find the slope of the tangent line. Okay, slope of the tangent line. Slope of the tangent line, okay, refers to the derivative. Okay, so here we go. What we need to do here, I'll do it over here. If g of x is f of x cubed, we need to find g prime because the derivative will give us the slope, okay? But if you notice that g of x is f of x cubed, there's actually a function f inside of the cubic function. So this will require the chain rule. So we take the derivative of the outside of the same inside times derivative of the inside. Okay, I'll get rid of that bar there. So specifically, we want to find the slope when x is, I believe, 3. Let me double check. Yep, when x is 3. So here we go. So we're going to plug in g of 3 equals 3 times f of 3 quantity squared times f prime of 3. Okay, that's the easy part. Now, everything in here is given to you, not explicitly. It's in the problem, but they want you to be able to find it. Now, f of 3, they give it to you right in part D. They tell you that f of 3 is negative 5 over 2. So what we're going to do is we're going to plug that in there. Negative 5 over 2, and then we're going to square that. Now, what's left is f prime of 3. How do we find that, right? So remember that they actually gave you a graph, and what did that graph represent, right? It represented f prime. So all you guys have to do is find out what f prime of 3 is. What is the value of f prime when x is 3? So right here, f prime of 3 is really just 4. Okay, again, it's not explicitly given, but they want you to know how to use it. That's enough for equal is equal right there. You could just leave it. No need to clean it up. That's that. Okay, notice how even if you didn't get the numerical answer, you could still get 2 points just for getting the chain rule right. Okay, so If you can't get full credit, always shoot for partial credit there.